like it means nothing.
I got a wand on my way here. I like that. It doesn't glow in here, but it's cool. Okay, so, I mean, hi Disobey. It's awesome to be here.
Yeah. This is a special one for us. The kind of journey 1 year ago started from here. And this is sort of like closing the circle at the same time. I mean, we have been, with this presentation, we have been at 3 different continents, delivering the talk in like largest stages in STÖK, and now we're back at home.
Where it all started. And what's cool about this is that, I mean, that's great and all. We collected shitloads of loots, but we got about 265 slides to go through in the next 45 minutes, so I think we should just get this show on the road, right?
Yeah, it's going to be hectic.
Very sweet. Okay, so I'm STÖK, this is Joohoi, and we're here because we're actually on tour for the release of our new album, Pure Scandinavian Darkness! Sweet. No, actually, we're here because we're going to talk about bit flips, space weather, heat, voltage, and other cool stuff that makes our devices go haywire and crazy and do idiotic things like fetching resources they weren't supposed to, or leak credentials to servers they're not intended to, and send emails to places that they definitely weren't intended to. Speaking of emails, I mean, who doesn't love a nice Slack token invite? I mean, that's sweet. And if we look into this domain, we can see here, this vismq.com. That's extremely close looking to the company we actually work for.
That's true. But wait a minute, actually, I think it's something else. So this is a typo. When we took a look at our keyboard, Q is basically right next to A. And we're not here for typos per se, right?
No, we're here to talk about bit flips. And bit flips is something totally different because they are not created by humans. It's computers doing computer kind of things.
Typos for computers.
Exactly. And what's really cool with bit flips is that all it takes is one single 1 to turn into 0 or 0 to turn into 1 to change everything. Because the thing is that if you take this domain, for instance, google.com, cool. It's built out the G is built out on all these 1s and 0s. And if you flip this G from 1 to 0, well, it turns into google.com. Change these 2 puppies here, it's google.com. Or if this one flips from 1 to 0, it's google.com. And google.com is cool, but if you take wordpress.com, for instance, and then you flip this one here, it's gorepress.com. And gorepress.com, you can actually go and buy this domain if you want to.
Or not. So, as I mentioned, we have done this talk a couple of times, and after the first talk, it's not available anymore. And it's not owned by us, so tread carefully.
We didn't buy it, somebody else did. Awesome. Anyway, and the technique here is called bitsquatting. And bitsquatting, was coined by Artem Dinenberg, and this was his Black Hat 11 talk. Super cool. He wrote a great paper that all of you should read that just breaks down how it works on the DNS level. It's super cool. And if we look into the kind of like if you Wikipedia this, the truth of the world, you'll understand that bitsquatting, and I'm just going to read this easier, is a form of cyber squatting, which relies on bit flip errors that occurs during the process of making a DNS request. These bit flips may occur due to factors such as faulty hardware or, hey, cosmic rays. Nice. When such error occurs, the user requested domain may be directed to a website registered under a domain that's similar to a legacy domain, except 1 bit flipped in their respective binary representations. And this is where I got super nerd sniped by Dylan A. Ray, because he told me a couple of years back that he bought koogleapis.com. And that is a domain that's extremely close to googleapis.com. And by running that on his VPS for a while, he collected shitloads of, due to Cosmic Rays, he collected shitloads of loot. And you might ask yourself, what is loot? Well, it's API tokens, JavaScript files, and all these other cool things. And at this stage, I'm like, ooh, I want to have me some of that. So I asked him, how can I do this? And he's like, it's super simple. All you need to do is to buy a couple of flip domains, catch all the DNS requests coming in, write some simple code, and then, store it in a log file.
I mean, easy, right?
Well, super easy. But since you are all smart people here, I want to break down how this flow works, because I wasn't in the beginning and I needed some help figuring it out. So the DNS HTTP request that Artem Dinenberg presented in his research works kind of like this. For instance, let's say that we're playing out with we didn't do WordPress, but it's like a proof of concept idea. So let's say you want to do an OAuth flow on WordPress. The client's going to request a DNS request going out, this inline DNS request, and talk to the root. That's going to give you a name server that's going to respond back with an IP address of the domain you want to connect to. The client is then going to connect to the web server and say like, hey, what's up? The web server is going to be nice, and then you just give stuff back. That's the first part of the flow. But imagine that, in this case, that some thingamajiggies happens, Cosmic Ray, Space Weather, whatever, that caused a bit flip in this. So a domain flips in the device's memory, turning WordPress into GorePress. Well, if this happened, what's going to happen now is that the client is going to talk to his inline server, but another name server is going to respond back and send that to the client. Client's all happy and going to post the next part of the dance to that server, which is cool. And I mean, that's the whole idea with the DNS and HTTP request.
Yeah, I mean, but it's 2025 now, so yeah, we are kind of, that concept was obviously valid for like 14 years ago.
Yeah.
But today, it would be something else.
Yeah, you were doing the same thing, boom, that's going to happen. You're going to get a warning and sad puppy, like nothing is going to work. And the reason why this happens this way for this domain, like OAuth.deb API something, has to do with certificates. And let's break down certificates for a second, because it's important when we go down the route. So a SON certificate, for instance, is a certificate that contains multiple predefined domain names. You can have shitloads of them. If you ever set up an Exchange server in the mid-2000s, this is the thing that you did. In our case, we probably moved into wildcards. So wildcards are cool, because if you have a wildcard, what it's going to do instead, that if you have star.gorepress.com, for instance, it's going to be able to respond with a secure connection for all these ones. It's going to be like www, blog, dev API, and whatever. So it's a cool thing. At
the same time, like nowadays, we know that the domain names that are used in production are long.long.long.long.long.
Yeah.
Right?
That's the problem. So if we were guessing what kind of certificate we will put in our certificate, and it's like aus.devapi.gorepress, that's a short one, that means that we're going to have challenges. Because if you're hitting this one here, that's not going to work, because it's one level down in your DNS naming kind of thing.
Yeah, and the wildcards in the SON certificates, they're only good for one level. Right?
Cool.
Yeah.
So that means that you're going to have two of these. So you need to have one for the original one, then the sub-level that you want to go to be able to serve it. So you need both these, and that's kind of the challenge that we're having. So you need all these, like this one and that one. Otherwise, it won't work. So when we were digging into this, we realized that it's easy, right? Well, the reality is actually that this is more what it actually was. So I had to set up a bind9 catch-all server and manually add in the text records, and then have an Nginx with a proxy that did the generation for me, and then write some really shitty Flask code that I had to manually just send the request, then enter and update this kind of app route to get the right certificate. And that was all cool and all with my 5 or 6 or 30 domains that I had, but I also had to renew them every 90 days. And at this stage, I'm like, okay, automation then, maybe that works. But at this stage, I'm so freaking tired of this project. So I'm like, nah, I don't know. I'm going to go out and do something else for a while. And I forgot about the project for about 2 years. Server was up and running, happy, shiny, until one day I got a nice email message from my VPS provider that says, "Dear value customer, your VPS McFlippy face is running out of disk space." I'm like, oh, that one, right? Like, I can remember this one. Cool project. It was a while ago. So logged into it and figured out, oh yeah, it's actually out of disk space. I wonder where that went. Well, it went in to the log files. And I had, over 2 years, collected shitloads of loot by accident.
Yeah, I mean, meanwhile at Finland. I love self-hosting for data privacy, all of that. Jazz, and I've been doing like self-hosting for the a better part of the last 20-something years. And for this presentation, just a reminder, the domains that you're going to see here, they're purely fictional, and they're used in this presentation because we want to respect the wishes of one of the targets, so to say, that you're going to see in a bit.
And they look cool.
Obviously, it's really cool. Like with a lo-fi, we're able to use these sort of graphics, and lo-fi is actually so cool of a domain that I would actually prefer to own that myself. And being such a cool domain, probably one of you owns that. But yeah.
Somebody already owns it.
Yeah, exactly. So this story begins with me registering a short domain, L0.fi, for this story. And when I kind of set up my shit, especially when it comes to email, I typically do something called catch-all configuration. So I'm able to basically get all the emails that come, regardless of the first part of the email address, to my inbox. And this allows me to do these unique usernames for each service that I use. So when that one party sells my data to a third party, I'm basically able to block them off and get rid of all of that. Oh, and also have the kind of a way to point fingers, like a shame on you. Never accepted this. No, I had this set up and running, and emails start flowing in. I get the testing emails that I send to myself, but then I also get these. Emails for a bank? I mean, so this is definitely not intended for me, so what is going on here? So L0.fi is my domain, and turns out LO.fi belongs to a bank. So these are basically the bank customers trying to reach somebody from the bank or some address, and they do a typo. O and 0 are basically right next to each other on the keyboard, and they also look the same. So yeah, that's the deal. I figure out what's going on. I do whatever a responsible researcher would do. I try to contact the bank security gang using email. I have this problem. There's no really kind of good technical solution, so but we would really still like to fix this. I don't want to be responsible for people's bank details. Could you do something, please? But no response. Probably there's no real kind of technical solution for that, so the security people were not able to kind of fix that, so they didn't reach out. I didn't give up. I called the bank. The poor tier 1 customer service agent who was like, oh, okay, it's me, like I have this sort of thing. Okay, I'll try to do my best. Didn't work out, didn't reach anyone. So, days go by, no fix, no response. I didn't reach anyone that could do anything about it, so I noticed something new in my email inbox. A lot of you probably know what this bad boy is.
Yes, please.
It's beautiful, and it's a scanner. So it scans things like contracts, stuff like that. And it's a typical piece of hardware in a bank branch office. And when you connect that to a network, it can also send stuff. And if it sends stuff, you better be sure that you configure that correctly. So you'll probably see where this is going. So now I'm actually receiving all of these like contracts from a scanner from the bank branch, and
PII Delaware.
I don't really want to deal with this shit. But yeah, I mean, still no response and all of that. So days go by, weeks go by, months go by, and it turns into a summer. So what do you do during the summer?
You go on vacation?
You go to a hacker camp. So this probably paints you a timeline here as well. 2017, there was a hacker camp called SHA, 2017 in Netherlands. I went there with a bunch of other awesome cool people. We were there. As a part of our village, there was also people from Finnish CERT, from Traficom. Huge kudos to these guys. I love you. They are basically part of the hacker community in Finland, enabling a lot of cool stuff.
Yeah, we can do some of that.
Do the applause. Thank you for everything you do. So, I told the kind of high-level issue that I had to one of their people, and they were like, "Oh shit!" They realized the issue right away. And they were like, "Okay, we have these connections. We are able to elevate these and get you connected with the relevant people there." I was like, "Yeah, sure. Like that's fucking awesome. Let's do that. But right now, I don't have my keys. I cannot access my infrastructure from here. So let's do that when we get home." When we get home, the guys do what they always do, guys and gals. They deliver. They connect me to a person in the bank, a lawyer. But, I mean, they did the right thing. The bank did the right thing. This was the best person available at the time. And, I know what you're thinking. That was what I was thinking initially as well. But the discussion was awesome. Like, we were able to solve it. Obviously, no real technical solution for this issue. So it ended up with me just, like signing off my domain to the bank. So they are able to kind of make sure I'm secure and, like taking a huge weight off my back as well. And this is where this story should end. But it doesn't. A couple of years in the future, I register a new domain. Remember this? This domain was L0.fi and the bank is LO.fi. I register a new one, KI.fi. Set my stuff up as I do. Boom! Hey, the bank customers are back. What is going on in there? It's a one-off error. Misplacement of a hand on a keyboard. One step away.
Easy fix.
Yeah. So I'm now the kind of Finnish information security kind of communications to the scene, all of that has matured a bit, and I have a direct contact, and it's like, hey, it's me again. Never guess what. And this time, obviously, the same thing, but I'm not going to give it like you're not going to be able to register all the domains. But the bank did the most awesome thing in the end. Not probably because of this. They promised to elevate that to their risk people and so on. But in the end, they actually got rid of the customer initial kind of communication emails altogether. Everything is handled within the application. I have a love-hate relationship with email, and I approve this. So it was good. Thank you for this unknown bank for doing this thing. And this is where this story actually ends.
But it's actually the beginning of something else, because at Disbay last year, I was speaking at Disbay last year, Jon was speaking at Disbay, and we're sitting backstage because, we're friends, we're having a good time, and I explained to him all about all the loot that I found. And I also explained like how tedious my whole kind of setup was to get it up and running. So I asked him like, is there any way, with your coding skills or whatever, could we do this a little bit better? And we talked about different situations that we could do. And
yeah, I mean, like there's a lot of things that we can do. Like we can improve the automation side of things like better together, but it's still kind of lacking. we're missing features that we would like to have in this kind of collection method in order to prove the previous research. So instead of actually going this like a gruesome automation, trying to patch shit together, what if we scrapped the whole thing and actually wrote this whole stack from scratch? I mean, like, we're not young guys, and we have limited time at our hands.
We're at 4 NEPAs in now.
Yeah, this is 4 NEPAs in sort of discussion here. So maybe can we muster up the energy and speed to actually like pull this off? What do you think?
Absolutely.
Yeah.
Oh, yeah.
4 NEPA speaking.
So that's what we did. So we trashed the whole shit, and we actually built a custom DNS server, custom HTTP server, custom mail server, certificate management, payload injection capabilities. Support for multiple protocols, I love it! Extended config file, because everybody needs to be able to customize their own build. JSON format for logging for extended thing that's going to work in the end. And then an easy 5-minute setup. That was shitloads of work, no joke. But it gave the birth to Certainly. And Certainly is a tool that listens to whatever happens and says yes to everything. It has the capability to deliver on-the-fly certificate generation and inject custom payloads. And it has a first-class credential logging service, which means that we will log your credentials safely in our log files. Thank you. Cool. So remember, now we had this idea, like, oh, it's a proof of concept kind of idea. So remember this thing, when it flipped in memory the second part of the whole like authentication dance. Flips in memory, W turns into G, now it's WordPress. What's going to happen? It's going to talk to inline DNS. In this case, Certainly it's going to respond. And what Certainly does in this case, Certainly is just responding and super happy in this case. So what will happen? IPs to the Certainly instances coming back on the any wildcard response of the DNS request coming in. So we'll wildcard responding on any kind of stuff that happens. Initially, in the first part, we put in DNS poisoning. And we thought that was cool, because what we did is that we not only responded to the flip domain that we had, we also responded with the IP address of the original domain, confusing the DNS cache of the upstream DNS server. That seems to be extremely dangerous, because we took some things down and got really worried. So now we implemented a 1-second time to live instead and removed the poisoning. But it's open source, so I'm just saying. Anyway, the response is coming back to the client, and the client's super happy at this stage. So what he's going to do is like, oh, cool, IP, I want to talk to you, Certainly server.
Yeah, and basically this is where the TLS negotiation pops up. So for you, all of you that know how the TLS negotiation basically works, that client first starts by sending in the client hello that tells the domain that they are trying to connect. And
if it's the wrong one, it's going to drop it.
Yeah, usually, yeah. And the server here, being Certainly, obviously kind of doesn't say yes yet, but instead says that, hold up. And and it actually pauses the TCP session. So the client is basically waiting for the server to respond with the certificates for the domain that they requested. So behind the scenes, Certainly is going to run to the CA and say, hey, I have this customer waiting. I would appreciate if you could speed things up and actually kind of get me a valid certificate for this thing. I can definitely prove that I own this domain.
For sure.
And remember, the client is trying to connect to the flip domain. So we actually do own that. So Certainly is a DNS server and all of the other things, it's able to easily prove the ownership of that domain by just sending the Acme DNS validation token into the DNS response. And CA is obviously super happy with the response. They were quick, they're good. So we're going to sign up the certificate and get them on their way. Certainly accepts that and delivers the certificate back to the waiting client and releases the TCP flow.
And this takes about 4 seconds.
On average.
So client doesn't time out. So since the client now gets this valid certificate, it's going to be super happy going back and then just sending whatever post token that is intended to be sending. And what we do, we smash that obviously into logs, but this is the genius part. Instead of just dropping it here, we're going to 307 to the original domain and just slightly walk out the door.
I mean, we're not the bad guys here.
So the client's just going to get back and talk to the original server and super happy and their flow works and they're good because we realized that if you treat your clients right, they are becoming returning customers. And we like that because that gives us the possibility to get the next part of the dance. Usually, you'll do the first request, giving it to them, second part. That's where the loot lies. Nice. And we thought that was cool, but that wasn't enough. Since we were able to control the flow, we thought about, how about adding a bit of injection support here?
Well, now we're the bad guys. I guess.
Bad guy-ish.
Yeah, we just want to prove a point. So yeah, the way that the injection obviously works is that the client is going to connect certainly is going to ask them to wait for a bit, and while the client is waiting, certainly is actually going in the background and connecting using all the client request headers as well intact, going back in the background to the original server, basically acting as a proxy.
Look at me, I'm you now.
Yeah. We're basically able to inject anything to authenticated request, all of that. So the server responds with whatever they do. Certainly we'll take that response and,
Based on the template?
Based on the template, it's going to do its stuff. So injecting the spicy stuff here and returning the spiced up response intact, by the way, with the response headers from the original upstream server back to the client.
So just imagine for a second, because this is sweet. What happens if you inject stuff into JavaScript? What happens if you inject stuff into JSON response? Well, shitloads of possibilities. So now I figured that you guys are sitting there, oh, cool, but how do I get the domains? I want to get that. Well, Luke Young did a really cool talk at DEF CON, but he tried to get as many domains as possible in sheep. So check out that talk. But what he also did is that he released a tool called BF Lookup. And BF Lookup, super easy. All it does is that you take a domain, you smash it in, and you're going to get a result back on the flip domains of that you put in that are available for you to register. In these cases, you can see all the ones that have a name server here, they're already taken. The rest of them are available to you to purchase at this time.
We actually haven't updated this data, so your mileage may vary.
Yes, because when we did this, as a part of the proof of concept, we did that. It means that in theory, we had the possibility to buy, or had to buy, 28 domains when it comes to WordPress, because there was a lot of other things. And that was not a big problem in theory to buy those, because they get you on the renewal, because that's where it starts to get really expensive. If you want to do this long term, you want to own these domains, that's where it gets really expensive. So we needed to find a way to funnel down. And one thing that I thought of during this part is like, okay, how can which are the domains that I should actually buy? So I looked into this really cool research here, where they actually do some experiments of seeing like, what is the most likely? A 1 turning to 0, 0 turning to a 1. And looking at this graph here, we can see that, okay, it's most probably that a 1 will turn into a 0, but a 0 turns into 1. But the reason why this turns from 1 turns into 0 has something to do with, it requires more energy to keep the 1 charged and letting it go in some way, but it's out of my kind of league.
I mean, like everything else in this area, it works with electricity and magic.
Electricity and magic. So if we take, and so I approached this with ideas. Okay, which are the characters in the alphabet that are that are DNS standards that have most ones in them? Well, it's O and it's W, and these are cool because they have shitloads of siblings, which means that O can turn into K, G, M, N, and L. W is V, S, G, C, P, just by flipping a bit from one to another. But they are far from alone. There's a lot of these siblings that are there, but they just, some of them aren't like as many, but the O and W are the ones that have the most.
Yeah, by the way, folks there in the back, are you able to see the last line here? Yeah, just wondering, yeah. I would have had some like referral links. And anyway, yeah, let's go on. Yeah.
On the other note, the ones that have the most zeros are A and B. So if we, for instance, if we look at this A and B here, and we flip this one from 1 to 0, what's going to happen is that it's going to turn into a capital character, like a char. And if you ever seen these kind of DNS entries that looks all leaked and shit, it's a flip that happened in transit.
Yeah, I mean,
because nobody's sitting there and writing like erg.
And I mean, like, we don't really care about that because DNS doesn't care about the case.
DNS doesn't care, and that's perfect. So, but instead we take all these ones here and flip those, what's going to happen is that, well, and A, I mean, it's good, but B turns into, B goes from B to a backtick.
I mean, we do love, especially all the offensive security practitioners, really love like backticks here, but they're not really useful for us in this context. But,
so we're not doing that because it's not going to work with DNS.
Yeah.
And we're primarily focused on getting the requests coming in.
Yeah.
So this is just to show an anomaly. And remember, like all it takes is this 1 to turn into 0 on one of these bits for WordPress to turn into WordPress. And that's just like super interesting. So I tried to do the math, like, okay, we did some research. Which of these that then the siblings are the most likely that O and W would turn into? Well, it shows up that even though they have like these possibilities, the ones that rank the best is that O likes to turn into K. Then it's G and it's M in that order. And that's super interesting because we started to look into this and we realized that, oh yeah, somebody has actually registered the WordPress. So somebody else is thinking about this. And that's great. We are not the only bad guys. So if we're supposed to buy any of these domains, the highest probability ones to flip are these ones. And obviously, WordPress is taken. But if we were doing this, this was kind of the approach that we would go down to.
Yeah, I mean, this is pretty cool. But maybe could we have more impact by targeting the top-level domains?
Thank you for asking. Yes. So I did the thing that, first of all, I did the thing that you should do. You get into the IANA database and you'll ask, how many of these do you have? And currently, at this time we did that, it was 1,447 TLDs. And out of those, actually one line needs to be removed. So I took all those and did the things that all the cool kids do now. I smashed it into ChatGPT and asked it, make a Python script to see which one match up. And I didn't expect this, but 348 of those actually turn into something else. Like IO turns into .im, for instance, or .nike turns into .like. So knowing this, .im is actually the Isle of Man. You can buy a domain here for about 20 euros. Somebody else did buy metamask.im, not us. But I bought a bunch of them. And I can say that it's super cool to see like a whole TLD flip because you get really weird things coming in. So that's made me like dream about .com. That would be epic. And actually, .com flips to .bomb. And .bomb is a new and upcoming domain, which in Portuguese means good, apparently. You can pre-register stuff there, and I'm now the proud owner of pre-registration on Amazon.bomb.
Well, I mean, like STÖK, this is cool and all, but hold your horses because that's not like the registration. I would assume that the random,
likeliness that I get it.
Yeah, hacker from Sweden probably is not going to be the one that's but yeah, we'll see.
If it works, it works. I mean, and the most dreamy one would obviously be like you remember O turns into K, most likely. That KCM, that doesn't exist. But
yeah, there's a way, a whole process how like these vanity or new TLDs do get registered, but it's not sort of it's not the same thing as you know purchasing a domain. I probably think that not too many people in this room actually have good enough like a credit for like a credit limit in their credit card to pay the evaluation fee of 185K. And by the way, this is not a purchase. Evaluation fee. So in case you like get enough bad intentions to decide to go that route, make sure that you have a really good justification why you would be the perfect owner for this TLD, because otherwise it's going to be costly.
And the application today is like a very short window every 7 years. So
yeah, exactly. Yeah.
It's harsh. You need a lot of cash and then be right on time. But we set out this whole adventure of proving that cosmic space rays is the thingamajig that breaks all these things, because that's the common idea. We thought that that was the thing, so we wanted to prove it, finally. That's why we built Certainly. And since we had Certainly, we wanted to replicate all the results for science, because that's what you do. So doing bitsquatting, we bought about, 25 domains or so from modern cloud, SaaS, package repos, and providers and applications that I know you use on a daily basis, because I do.
I don't know, by the way.
But the cool thing is that we wanted high traffic domains. So think about these that generate a lot of traffic, because if you register Bitflip for your 15 visitor a month kind of thing, it's not gonna give you the fruit that you want. So you want the high traffic ones. And then we spin up Certainly, and we let that run without interruption for 4 months and 23 days, waiting patiently for something to happen. And boy, did we get lucky.
I mean, we were at the perfect spot at this moment. We had our infrastructure running.
Stable build.
Yeah, Certainly was running, picking up like all of these like things coming in towards its way.
Optimized domains.
Yeah.
So on May the 10th, 2024, the world got hit by the strongest solar storms in 20 years. So we're like, perfect storm!
Bring it on, bring it on.
This is us at that time. So super excited about this thing. And it's like,
this is it.
Gonna be epic.
Let's go.
And then we sit in there and we agreed that we should not look at the logs. We cannot look at logs until the storm settles. And then the day comes, then it's a low kind of storm and nothing.
Yeah. Actually, if you look at the graph here, it's lower than average. Disappointed!
Exactly. So,
yeah. I mean, like, what's going on here? Actually, 6 months ago, we had already we were actually on our way to Vegas to present the whole thing in Black Hat.
And just ready to say, it fucked up.
Yep.
We couldn't prove it.
This paper dropped. Research into correlation between DRAM errors and the cosmic rays. Research done by the Barcelona Supercomputing Center, European Space Agency, and the University of Athens.
For a very long time.
Yeah, they have a huge data set for the research. They did look into like different altitudes of the hardware and all of that. And in their conclusion, we find no correlation. And in fact, they recommend the people who did previous research on this topic to actually revisit their research in the light of this information.
That sucks, because I thought that space rays were the whole idea, that this happened. But the fact remains, during this test period, we collected about 62 million incoming DNS requests. That turned into 2.8 million signed HTTPS requests coming in to our service, and about 15,000 emails during that period.
That's a lot of Viagra. But also, you may remember this bad boy. They are back as well.
And suddenly it seems like somebody's like Konica, Minolta, E-tag scanning shit, and we randomly got that.
This is not the bank, by the way. But
That's not the bad part. The bad part is this. We collected about 2,300 unique OAuth and authentication tokens for multiple Fortune 500 companies that were using these kind of services. That's account takeovers. And boy, many of these came back multiple times.
oops.
Because if you treat your client nice, they're returning customers. And we also realized that a really cool way to use this was to do like the split horizon kind of thing.
Yeah, split horizon DNS, you know, when you have like a different DNS responses for your internal network, some of the infrastructure or the kind of all of that is not visible for the public internet. And but with a bit flip scenario, if the target domain flips, boom, it goes, well, depending on the egress rules, obviously, it goes to the outer space.
So it's a super good way for us to create brute force DNS lists for companies that we want to break into or help.
Passively.
Absolutely.
Just collect.
We also got shitloads of the freshest scanners things that hit our boxes because every time a new certificate was generated, in the beginning we did SON certificates before we moved into wildcards. The scanner boys came running and threw the latest payloads in our stuff, so we just picked the cherries and just had a good time.
Yeah. So yeah, this is quite a lot to take in, and some of you may be like wondering, what can we do about it?
Yeah.
Well, the boring answer is the traditional one. For whatever you can, take the responsibility and start working on it. So the most obvious answer, obviously, here is to kind of get the domains that are kind of parallel.
At least the priority ones.
Yeah, the most important ones. And as we can see here, by the way, WordPress was not one of our targets for the research. But yeah, if you look at WordPress here, there's actually quite a few to reserve. So don't be like WordPress, but be like Amazon instead. They got it all. They were like forward thinking there. So another thing that you can do is certificate pinning. And you may be, okay, but yeah, certificate pinning has not been available for general browser for years. And that's true, for a good reason, by the way. But we actually see a huge overrepresentation of mobile application, mobile hardware in our dataset. So this is definitely a valid thing. But if you go that route, make sure they implement that right. So we were talking about one of the major social media companies about this, like we got some data for them. And they were like, okay, but it's not really not an issue.
We have cert pinning.
Yeah, we are doing cert pinning. They were. That's right. But their cert pinning was implemented in a way that they basically had a list of domains, and they're basically expected fingerprints of the certificates. But if the domain is a flip domain, it's not found in the map. It's not found in the list. So they fail open. And we're back at the, yeah.
It's by design. I mean, we buy that, but the thing is that we flip in memory.
Yeah.
So it's the legit one.
Yeah, exactly.
We got about 2 minutes.
Okay, let's go. So one of my favorite ones is doing the OpenBSD thing. OpenBSD pledge is something that we could practically implement in core networking libraries, and basically upon application initialization, give it a list of domains that we're expecting to be communicating with. And if the kind of on a certificate validation phase, we see something else coming in, we just blackout, kill the connection.
And that's great. Or we can do the thing that most companies did, blame it on DNS. And then just live blissfully and not do anything about it.
At the same time, though, you end up taking the responsibility in this approach as well. So
it's cool, and I don't blame you. I'm just going to keep getting the creds. And the thing is that you might ask yourself, because we did, like, why does this even happen? And the full transparent answer is that we have no idea. And that's why this is a call for research, because the whole conception about bit flips is that people thought that, well, it rarely happens, so we don't need to think about it. Well, we built a tool now, so I think the reason why things didn't show up is because it rarely got caught. Because we see a high representation of apps and devices and custom code and all that stuff that's happening. And maybe it has to do something with a row hammer thing, reading in the memory of the domain and, rapidly acting stuff. It could be the CPU cache or CPU or memory, or it could be the networking library.
Snipe. So we definitely got like really deep into this thing, and we're like after every corner we found something new and inspiring. So we got really deep into the rabbit hole, and we hope that part of this presentation was able to kind of do the same thing for you as well.
Yes, we nerd out, and to make sure that everyone can nerd out on these, we released certainly as open source MIT. So you can use that. Thank you. So if you want to, you can get into github.com/happycakefriends/certainly.
Happy Cake Friends, because we're obviously friendly and not malicious as well, so,
And we got
cute.
stickers and all, so, we're obviously real and, serious. That being said, this is Joohoi. I'm at STÖK Critic, and thank you for coming to our talk.
Yep, thank you.